Okay, and now we'll talk about operations on single random variable, which is operation on a single random variable. Here we know that the operations are like basically mean, variance, and moment. So first of all, we'll go for mean. What is mean? Which is expectation, mean or expectation of a random variable, which is also known as first order moment. It is shown by expectation of x equal to x into f of x into f of x dx, which, or we can also say it, if it is discrete, we can say it summation of x into f of x. Okay, this will become your mean. And now we'll talk about properties of mean. Properties of mean, it will be, property is, for a constant, mean will be a constant only, and for, if any this random variable is multiplied by k, the expectation becomes k times of this random variable expectation. And coming to the point, this, if random variable is multiplied by k1 and then some random variable some random value is k2 is added, which is a constant, then k1 will come outside, and this expectation plus k2 is a constant, so it will stay. And similarly, when suppose there are two functions of random, there are two different functions of random variable x, like suppose g1x and g2 of x, then what will happen? Expectation of g1 of x plus g2 of x will be, individually we can take the expectation, like expectation of g1x plus expectation of g2 of x, this way, right? And also this expectation square is equal to, this is called a mean square, which is equal to, not mean square exactly, but means a square. Okay, this becomes your dc power. Okay, and then we'll come to second topic, which is second order moment, also known as mean square value. Here doesn't mean mean is squared. Okay, here what does it mean is the mean of square of random variable, which is equal to that random variable square, the function distribution function, sorry density function, then we will integrate over the time, and this gives us total power. RMS value gives total power, right? Also we can write it for discrete variables, expectation x square f of x, and we'll sum it. Okay, this becomes your second order moment. And then second thing is, first, what will be next, we'll moving to next point. This is first order central moment, first order central moment of random variable. So this will be what, it means like central or first order central moment. Central moment means the moment across the mean, right? Which will be, since mu x is a constant, we can take expectation minus mu x. So this is first order, right? That's why, and it will become 0, correct? So first order central moment, it will be completely 0. And now we'll move to second order. Then if we move to second order, remember this is central moment. Okay, second order central moment of random variable, what it will be? It will be your mean square value minus mean square. This is your complete result. Okay, now if you ask me how, because second order central moment means what? Second order, what is central moment? Central moment, this is second order, that means square, and then find the expectation. So this becomes what? E to the x square plus mu x square minus 2 x mu x. And using the properties you can easily prove it. Plus mu x square minus 2 mu x square, which gives us expectation of x square minus expectation of x then whole square, right? Which is equal to the here variance, which gives variance equal to mean square value minus mean square. And remember, this gives you AC power. Okay, so repeating again, mean square, this gives your DC power. Okay, while variance, which is equal to mean square value minus mean square, gives your AC power. Okay, and then we'll talk about the properties of this variance. So coming to the properties, variance of a constant. Think variance is what? It is center, like moment of second order moment, second order central moment, right? Again constant, right? So mean will be constant, so it becomes 0. And variance of k multiplied by x, if you multiply with variance some constant k, then what will happen? We are squaring it, right? If you remember, then it becomes k square times of variance of x, correct? Similarly, suppose we multiply with k and add some k2. Again, constant we are adding, right? So constant variance like central moment, right? So that will become 0. So that means k square variance of x plus 0, right? This is clear, right? Okay. And then